Ramjets and scramjets are two types of air-breathing engines that use the atmosphere as their source of oxygen, instead of carrying their own oxygen on board like traditional rocket engines do. These engines are actually designed to operate at really high speeds, typically above Mach 3, which is around 2,000 miles per hour or about 3,200 kilometers per hour. They're used to power aircraft and missiles that need high-speed propulsion. A ramjet is a type of air-breathing engine that uses the atmosphere as its source of oxygen to combust fuel. The engine itself consists of an inlet, a combustion chamber, and a nozzle. Now here's how it works. First, the inlet captures the atmosphere and slows it down, reducing the speed of the air from supersonic to subsonic. This actually creates a region of high pressure and temperature right behind the inlet. Next, in the combustion chamber, fuel, usually in the form of liquid or solid propellant, is injected, where it mixes with that high-pressure, high-temperature air. Then comes combustion. The fuel-air mixture ignites, producing a high-speed gas that expands and accelerates out of the combustion chamber. Finally, the hot gas is expelled through a nozzle, which accelerates it to high speeds, typically above Mach 5, or about 3,800 miles per hour. That's roughly 6,100 kilometers per hour. The key advantage of ramjets is that they can operate efficiently at high speeds, above Mach 3, and they can provide a significant amount of thrust. However, ramjets do have some limitations. There's limited acceleration. Ramjets can only accelerate an aircraft or missile to a certain speed, usually around Mach 5, before the engine becomes inefficient. Another thing is high altitude limits. Ramjets need a significant amount of air to operate, which actually limits their altitude range. At high altitudes, the air density is just too low to support efficient combustion. Ramjets have been used in various applications, including missiles like the AGM-136T SAM from the United States and the P-800 Onyx from Russia, both of which use ramjet engines. In terms of aircraft, the Lockheed D-21 tagboard from the United States and the MBDA Astra from France also use ramjet engines. So, let's talk about scramjets. A scramjet, which stands for supersonic combustion ramjet, is a really advanced type of air-breathing engine that, uses the atmosphere as its source of oxygen to combust fuel. Scramjets are actually designed to operate at even higher speeds than ramjets, usually above Mach 5, which is about 3,800 miles per hour or 6,100 kilometers per hour. The main difference between scramjets and ramjets is all about the combustion process. In a scramjet, the air isn't slowed down to subsonic speeds before combustion. Instead, the fuel is injected straight into the supersonic airflow, and combustion happens at those supersonic speeds. Plus, scramjets don't need a compression process since the air is already compressed by the high-speed airflow. Scramjets, well, they've got quite a few advantages over ramjets. For one thing, they can operate at much higher speeds, potentially above Mach 10, which is about 7,600 miles per hour or 12,200 kilometers per hour. They've also got improved efficiency, since scramjets can achieve higher specific impulse, a measure of efficiency, because of that supersonic combustion process. But there are some significant challenges too. Scramjets need a really reliable ignition system, since the air and fuel have to ignite at supersonic speeds, which isn't easy. And then there's the issue of materials. The high-speed airflow and combustion process in scramjets can generate extremely high temperatures, which can actually damage engine materials. Scramjets are still in the experimental phase, but, several countries have developed scramjet-powered vehicles. NASA's X-43A was a demonstration vehicle that reached Mach 9.6, which is about 7,200 miles per hour, or 11,600 kilometers per hour, back in 2004. Australia's University of Queensland successfully tested a scramjet-powered vehicle in 2013. And India's Hypersonic Technology Demonstrator Vehicle, or HSTDV, was successfully tested as a scramjet-powered vehicle in 2020. There are some key differences between ramjets and scramjets. First, the combustion process. Ramjets use subsonic combustion, while scramjets use supersonic combustion. Second, the speed range ramjets are typically limited to speeds below Mach 5, while scramjets can operate at speeds above Mach 5. Third, compression. Ramjets require compression to slow down the air, while scramjets do not require compression. And finally, efficiency scramjets have the potential to achieve higher specific impulse than ramjets. Aircraft and missiles powered by ramjets and scramjets include, for example, the AGM-136 TSAM from the United States, which is a ramjet-powered anti-radar missile. There's the P-800 Onyx from Russia, a ramjet-powered anti-ship missile. The Lockheed D-21 Tagboard from the United States is a ramjet-powered reconnaissance drone. MBDA Aster from France is a ramjet-powered surface-to-air missile. Now for scramjet-powered vehicles, there's NASA's X-43A from the United States, the University of Queensland's Scramjet from Australia, and India's Hypersonic Technology Demonstrator Vehicle, or HSTDV. In conclusion, ramjets and scramjets are two types of air-breathing engines that use the atmosphere as their source of oxygen to combust fuel. While ramjets have been used in various applications, scramjets are still in the experimental phase, offering the potential for higher speeds and improved efficiency. The key differences between ramjets and scramjets really come down to their combustion processes, speed ranges, and compression requirements. Here are some examples of missiles and aircraft that use ramjet and scramjet propulsion. Ramjet-powered missiles and aircraft. 1. MGM-52. Lance, a U.S. tactical missile that uses a ramjet engine for propulsion. 2. SA-6 Gainful, a Soviet surface-to-air missile that employs a ramjet engine. 3. Mach, a U.S. surface-to-air missile that uses a ramjet engine. 4. Bloodhound, a British surface-to-air missile that employs a ramjet engine. 5. Lockheed X-7, an experimental U.S. aircraft that tested ramjet engines. 6. Navajo, a U.S. cruise missile project that used ramjet engines. Scramjet-powered missiles and aircraft. 1. X-51 Wave Rider, a U.S. experimental hypersonic aircraft that uses a scramjet engine. 2. Hishot, an Australian experimental hypersonic aircraft that tested scramjet engines. 3. X-43, a U.S. experimental hypersonic aircraft that used a scramjet engine. 4. HTV-2, a U.S. hypersonic test vehicle that employs a scramjet engine. 5. DFZF, a Chinese hypersonic glide vehicle that uses a scramjet engine. 6. BrahMos-2, an Indian-Russian hypersonic cruise missile project that aims to use scramjet engines. Note that scramjet engines are still in the design and experimental phase, and most of the examples listed above are research projects or prototypes. It is hoped that in the near future, these prototypes would come into reality and cause a radical change in jet propulsion technologies in the design and use, if missiles and aircrafts, both in war and peace times,